Welcome back, guys. Here's a couple of practice problems. We're not going to do this verify thing. I just kind of discovered these moments ago. We're not going to do this part. We already did a cosine one. Let's do maybe this 1 over x one. So for b, the average value of this function is 1 over b minus a. So 4 minus 1 is 3. And the integral from a to b of that function. I'm going to write it as x to the minus 1 because that's what I'm going to do anyways. 1 over x to the minus 1. The antiderivative of this is the natural log of x. So I do 1/3 times the log of x running from 4 to 1, which is 1/3 times log 4 times log of 1. Log of 1 is 0, so 1/3 log 4. And this says verify with fn int. That means like use your calculator's integration thing to get to basically to ensure that the integral of this thing is 1 over x, I guess. I don't know. This is the average value. For c, you do something similar, 0 to pi over 4. So 1 over b minus a is pi over 4 times the integral from 0 to pi over 4 of secant x tangent x dx. The antiderivative of secant tangent, well, actually, this first thing, the pi over 4 becomes 4 over pi. This is reciprocal. Antiderivative of secant tangent is just secant. So secant x running from pi over 4 to 0. You remember your unit circle, secant is 1 over cosine. Cosine pi over 4 is essentially root 2. This was 1 over cosine. So it's 1, yeah, okay. So 4 over pi times, I'll write it out, secant of pi over 4 minus secant of 0. Secant of pi over 4 is square root of 2, and secant of 0 is 1. So this number, this is the answer. So that's how you do this. 1 over b minus a times integral from a to b of x dx. And that's for average value, remember, not average rate of change. So some kind of relatively quick notes about accumulation now. So the velocity of a car is given by this function f of t for 0 to 5. What does the derivative of that function represent? It's like derivatives are rates of change. And if this function is a velocity, the rate of change of velocity is acceleration. That's important to know. They tend to, on these AP tests, they tend to start with velocities because you can go both directions. And what I mean is, what does the integral represent from 0 to 5? It's like an accumulation, right? That's what I mean when I say accumulations. I mean like this thing accumulates, it adds things up. And when it's adding up here, if we know that this is a velocity and it's in like meters per second, and this dt is the time and it's in seconds, what's accumulating is meters, it's accumulating distance. And specifically, it accumulates the displacement of the car from 0 to 5 seconds. It says, I wrote meters, it doesn't say what the unit is, but I use meters, whatever. That means displacement of the car in meters and feet and miles, whatever, from 0 to 5 seconds. And displacement is important because it's different from distance. They're subtly different. So displacement, this could be negative. Like if I go backwards, my displacement would be negative. But a distance traveled is always positive. I probably have said this before, but I think that you should think of distance traveled as like what would show up on the odometer in your car. Displacement is like, it has to be measured specifically from how far did I end up from where I began, regardless of how far, like the distance I traveled to get there. And in calculus, displacement is the integral of the velocity for some times A and B. The distance traveled is the absolute value of the velocity. times A to B. It's different. The absolute value makes this different. Absolute value. That's what makes this different. Because that's how, like, it means that the negative parts count as positive, basically. So this is the difference between displacement and distance travel. You can do both of these in your calculator. Like, you can do the absolute value in your calculator, which makes this kind of convenient. So that's what I did for this example. I just used my calculator. You could have done part A pretty easily without a calculator. You know the antiderivatives of each one of these things. So displacement here is the integral from 0 to 6 of this function. That's what displacement is. It's the integral of velocity. That's what we just saw here. Displacement, integral of velocity. So 0 to 6, I do t cubed minus 10t squared plus 24t dt. Like I said a minute ago, you could do these by hand. It's t to the 4th over 4 minus 10/3 t squared, or 10/3 t cubed plus blah, so on and so forth. And then you would plug in a 6 and the 0 would just disappear and you get a number. But I can tell you, if you did all that, you would get 36. I did it in my calculator. And that's fine, but that tells me displacement. And this is actually the graph of this curve. Just like the solid line here is the graph of v of t. But if I go with the absolute value, which would be total distance travel is the absolute value. Then like this part here from 4 to 6 where it goes negative is like a positive part. Like it bounces right there at 4 because it can't be negative, it's the absolute value. What that means is, like, instead of subtracting this area, when I do the integral, I'm adding that area again. When I do this, I get about 49 1/3, which is 148 thirds. And like the difference between these is like twice this area, right? So like that area is probably about 6.5 or something. So my point is like that if it asks you for displacement, you just want to do this. If it asks you for total distance, you want to do this. And if you don't know how to do absolute values in your calculator, I'm happy to show you in class or something. It's kind of a tricky thing to do on like in a video. So maybe we'll do these two examples and be done. This one's kind of hard. Make sure we do that in class together. There's a significant number of these are going to be done using your calculator. So make sure you bring your calculator class with you because the absolute value ones are pretty hard to do without it. So the bug begins to crawl up a vertical wire at time 0. It's a weird setup, but okay. The velocity of the bug at time t is given by the function graph is shown. So this is a velocity graph for a bug crawling on a wire. So the question is, when does a bug change direction? So this is not really an accumulation question. This is a question about bugs change direction. There's only two directions when b of t changes signs. So either positive to negative or negative to positive. That's when it's changing direction. B of t is actually the height of this graph. So it's positive, 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 negative. So it switches right there at 6. So the answer here is 6. But then the total distance, this is going to be like, you're going to find all of these, you're going to find this area, and you're going to find this area, but you're not going to subtract this area this time. The total distance means the absolute value. So you're like, whatever this area is plus whatever that area is. No negatives. Total distance, absolute value, okay? So we got us a trapezoid there. So 1/2, its height is 3. Its bases are from 0 to 6 is 6, plus, that looks like 2 to 4 is 2, plus, and this is a triangle, it's 1/2 times 2 times 1. Let's see, this is half of 8, which is 4 times 3 is 12, plus 1 is 13. There you go, total distance. Just got to make sure you're adding the two areas together. Not much to that. This is the same kind of a question. If this was a number 6, that means that this is a no calculator question, which is obnoxious because when it says total distance, you're like, how am I going to do absolute values of like this weird function without my calculator. And here's how. If this thing is positive the whole time, like, and by say the whole time, I mean from 0 to 3, if this thing is positive, then I don't have to worry about the absolute value. It's just the same as irregularity. It's just the same as regular antiderivative. Like basically, if v of t is greater than 0 from 0 to 3, then v of t is the same as the absolute value of v of t. That's kind of like the concept I'm using here. And y'all are gonna hate this, but if I like sketch the graph of this thing, I'm like, well, it's an upside down parabola, and I could rewrite it as t times 6 minus t. So if I set that equal to 0 to find where it hits the x-axis, I get it hits the x-axis at 0 and 6, which means it looks like this. So that's 6 and that's 0. So this thing, since it's asking me about from 0 to 3, I know it's positive the whole time. I'm basically going to find this area. So I don't have to actually worry about the total distance, but you have to like consider it. Because if it was negative, you'd have to figure out how to do the absolute value of that. But this one's not, so I'm just going to do, going to go from 0 to 3 of 6t minus t squared dt, which is, so you add 1 divided by the new power, 3t squared minus t cubed over 3, running from 3 to 0. 0 is just going to disappear. I have 3 times 9 minus 27 over 3, which is 27 minus 9, which is 18. Which is right here. So at the very least, you have to like, this problem, you didn't actually have to do an absolute value by hand, but you had to consider that it might be an absolute value there. Yeah, I'm gonna do this one in class. Remind me to do it. I hope you all learned something. Bye.